Okay, good morning. In this second part of our video about operating system, here we will go through like the notes that I made in the operating system, and I will be covering all of those. And yeah, I think that would be enough. But the second thing, if you wanted to learn more, is to read books. That will give you a far deeper understanding. But I think this is enough for doing it, and in our future video we might be covering or doing the questions for that have come and get. So here in the second part we just quickly revise, and then we just move on with our topics. Okay, so when operating system was were to be designed, there were two architectures. One of them is a von Neumann architectures, which we used currently. In von Neumann architecture, there is only a single bus which takes both the instruction and the data to the CPU, while the other architecture is the Howard architecture, which is in which data and instruction are carried by separate bus. But the difficulty in the Harvard architecture uh, is that of the synchronization. The instructions and the data need to be synchronized. And it is like a difficult job to synchronize that. So we use von Neumann architecture. In von Neumann architecture, what we follows is the follows stored program concept. What is a stored program concept is that the program, any program that is to be executed must be stored in the main memory. I have already said that it should be a stored program means it should be a process, or it should be in the main memory to be executed. No process, or I mean no program can be executed if it lies in the secondary storage. It has to be in the main memory, or some part of it has to be in the main memory. And while executing, if an operating system requires a part that is not in the main memory, it generates an interrupt, and that part will move from secondary storage to main memory, and then the CPU serves the request for that part of our program. So, uh, but in follow stored program concept, it follows sequence of instruction. In this sequence of instruction, basically there are three. First, we fetch the instruction. Then we decode the instruction, and then we execute the instruction. These cycles goes on, and it follows always the same path. If during decoding, if some part of a instruction, or the memory that instruction want resides in the secondary storage or not, or we can say better is during the decoding, if any data required by the instruction is not present in the main memory, then the system generates an interrupt, and that part of a program will brought from the secondary storage into the main memory, and then the program start executing. Okay, so operating system, in this diagram, as you can see, operating system acts as a translator. In simple terms, like the machine, or basically the CPU, expects instruction in the form of 0 and 1, and we gives most of our instruction in form of our languages, like alphabetical languages, which contains its characters from A to Z, and while that of computer understand only two things, which is 0 and 1. So we can also say that also acts as a translator. So yeah, in this diagram, memory has been divided into two parts. First is primary memory, which consists of RAM and ROM. Most people have the confusion that considered ROM as a secondary memory, which is wrong. RAM and ROM both is a part of a primary memory, while secondary storage can include like magnetic disk, your SSDs, pen drive, etc. Okay, so memory, in the von Neumann architecture, memory is connected directly to the control unit or the CPU, and memory contains both the data and the instruction, and there is only a single bridge which connects to the CPU. Uh, the control unit does two things. It generates timing signals, or like you can say, it controls the execution of instruction. Instruction are executed synchronously or in a timed manner. Untimed execution of instruction may lead to stalls, which not a good thing. And control unit works upon micro operations, operations which is further simplified. Like for example, is you can say micro operation is the basic unit, and multiple micro operation together forms a normal operation. Micro operation carried out on data in registers. Yeah, in micro operations everything works on register. Even the temporary result are also stored in the register. So this is a view of the operating system, or the whole computer system, you can say. In the bottom of it lies the hardware, which includes CPU, memory, and I/O devices, over which there is an OS kernel layer, which has, I mean, you can say that you distribute the interface is divided into two layers. One of them is like OS kernel layer L1, and other is like all the things like the GUI names. Okay. So kernel OS kernel layer interacts with the hardware, while uh, the layer 2, which includes shell or desktop, interacts with the user. So basically, it happens like for four bar. There is a user which interacts with an shell or desktop, or which we can say a GUI. Then that GUI interacts with the kernel layer, which translate into instructions which can be executed on the hardware. Yeah. So the functions we have already discussed. Functions includes memory management, uh, process management, IO management, file management, and etc. So goals and objectives are convenience, efficiency, robustness, reliability, portability, scalability, and many more. The primary goals are convenience and efficiency for the computers that we use. Convenience refers to easy to use, like our system needs to be easy to use. Efficiency, effective utilization of resources, and effective utilization of resources means different thing for different classes of devices. Like for as we have already covered in our previous video, different class of devices, like if you're using a mobile phone, then the most important resource become the power supply or the battery. So it should be very efficient in power consumption, while for desktop it should be as the power supply must be in abundance, so resource like such as memory becomes the more important part, and effective utilization of memory should be like uh, the most important part in that. Robustness is, you can say, like system generates error, and your system shall not stop if it encounters an error. It continues to work with few errors. That means robustness. Basically, you can other term to define robustness is redundancy. It bears few errors and it still continues to work. Reliability. You can say reliability like it covers all the listed specification. If you select an operating system and there are n specification listed that it fulfills, so it fulfills all the n is listed specifications. uh, Portability. Portability here in case means that it works for both different types of CPUs such as Intel, AMD, uh, and that Motorola, whatever that makes. But portability means here for operating system means that uh, your operating system can work on different type of devices, such as better than going into this is like the thing of which we are currently is like x86 architecture and the ARM architecture. Your process, your program shall should work in both uh, architecture, but which ensure portability, but it is not mandatory or like uh, the basic goal in our systems, because we know that the different type of applications works for our desktop Macs or that of our phone. Scalability is basically if you are a system designer, you must know that ability to evolve. Like initially when you start a project, or yeah, initially when you start a project, you have started with a certain specifications, but it should evolve with time, or your specification changes, so it must evolve with time. Yeah. The second topic is type of operating system. In type of operating system, there are multiple generation of this. The first generation is the punch card, which doesn't have an operating system. The second generation is the magnetic tape, which also does not have an operating system. So our first operating systems came with the third generation, which started in somewhere between 1950s and 60s. And that time the operating system are basically uni-programmed operating systems such as DOS, and which works on like a magnetic disk, and uh, which further evolve into like hard disk, floppy disk. Floppy disk comes in two sizes, 3.5 and 5.25 bay drives, and magnetic disk also divided like a uni-programmed and a multi-programmed operating system, which is your Unix, Linux, Mac OS, Windows, etc. So the first program that we encounter in our textbook is like a batch OS. So what is batch OS? Batch OS is simply like it's batches together the same types of jobs of and execute it. For means like there are n instructions, and there are 10 types of jobs. So each instruction is divided into those 10 jobs, and each jobs is become one batch, and then that batch executes, is known as batch operating system. In batch operating system is basically that user actually interacts with the hardware. It's like a bare bone operating system. User actually has to interact with the hardware, whereas in further module is lies are like the multi-programmed operating system and time sharing operating system. In Windows Fraternity, multi-programmed operating system is also known as multitasking operation. As in Windows, program is referred to as task, and when multiple task or the program is present in the memory, it becomes multi-programmed or multitasking operating system. Uh, yeah. Then advanced operating systems consist of real-time operating system, network operating system, and distributed operating system. Yeah, as we have discussed for about our goals. Yeah, Goals or the objective of operating system. So for this real-time operating system, it is the main objective or the main goal is not convenient or neither efficiency, is the time at which the results arrive. Also, for real-time operating systems, the objectives for our objectives totally changes. Which is the main objectives is totally changes with respect to our desktop and PCs. So, uni-programmed operating system. What is uni-programmed operating system? Uni-programmed operating systems are those operating systems in which only one program is present other than the kernel itself or the operating system itself. So, ability of OS to load and manage a single program in memory. Only one program is present in a memory, and example of uni-programmed operating systems are DOS and batch operating system. See, every memory is divided in two parts. First is the system area, and the other area is named the other area. In system area, operating system resides, and other areas the program resides. So in uni-programmed operating system, only one program resides in the other areas, and that program runs on CPU and goes for IO operations. While disk may contains more than one program, but only one process is present in the memory. I might have interchanged or used the program and process, the term program and process interchangeably, but I have already clarified the difference between these two in my earlier part. So the limitations of the uni-programmed operating system are idealness of CPU. While that one process which is executing on CPUs goes for IO operations, the CPU remains idle and does not execute any other instruction. Therefore, CPU remains ideal, and the idealness of CPU causes low throughput. Low throughput means that the number of jobs computed per unit time. Throughput means number of jobs that are yes. So low throughput means number of jobs computed per unit times are less. To solve these low throughput and multiple process to be present in memory, the next operating systems comes, which comes as multi-programming operating system. So it is defined as ability of an operating system to hold multiple ready to execute, means those process that are ready to be executed at a moment notice in memory. So that if any running program relinquish CPU, which means goes for IO operations or execute system calls, then the CPU can be switched to another ready program from memory. Okay. Uh, like types of if if you are playing if you take a real example, or like you were watching a movie and then suddenly a phone comes, while you pause the movie you are going to attend a phone call. So that type of operating system is comes under multi-programming operating system, in which one process is interrupted or switch to another process which is present in the memory, like a phone call, or yeah, you got the idea about the other process. So types of multi-programming is majorly divided into two types: non-preemptive and preemptive. Types of multi-program is divided into two types: non-preemptive and preemptive multi-programming. Non-preemptive examples of non-preemptive are Windows 3.0 and Windows 3.1, and non-preemptive examples are like Windows X95, XP, Linux, Mac, Windows 10, 11, whatever, anything other than non-preemptive. Most of the operating system that we use currently are part of preemptive operating systems, Android, iOS, whatever. So, non-preemptive, there is only a voluntary release of CPU. For example, if a process is using a CPU, only that process is entitled to leave the CPU. No other process can pimp out the CPU. Can pimp out the running um, process from the CPU. Voluntary release only happen during the completion or when the process has gone for the IO. While preemptive, the limitations are lack of interactiveness, which leads to starvation. Only when only a process P1 gets completed or goes for IO, then only P2 is loaded. So if we kept that the same example for of the movie, unless the movie completed, you cannot attend the phone call. So which reduce the interactiveness, and your phone call will goes into starvation until the movie completes. In preemptive, there is forceful deallocation from the CPU. Forceful deallocations means if you are running if a process P1 is running on the CPU and some higher priority process or any other process want to execute a certain instruction, then that process P naught or any other process can forcefully deallocate P1 from the CPU and execute itself. This process of forceful deallocation is done by kernel, or basically like it's not, if you can say, it's like the privileged instructions or the system calls are required to remove the executing the running process from CPU. Okay. So forceful deallocation can be due to completion, IO, priority. Certain instructions such as system calls have higher priority and can deallocate the currently executing instruction, and other is time. Time means multi-program timed operating system. Yeah, like a certain amount of time is given for a process for a process to run, and after that time, that process has been deallocated, and another process will run. Yeah. So, as I have already said, that multitasking is the term defined by Microsoft, which means preemptive multi-programming. Okay, so multi-processing. Multiprocessing is a system in which there are multiple processor, and each processor can execute a new process. Means if there are n CPUs in a system, then that system can execute an process in a real or physical parallelism. Then architecture support for implementation of multi-programming operating system uh, is hardware. Basically, we are talking about the hardware support. Is first the IO devices, direct memory access, DMA access, memory system address translation, and the third is CPU, which supports dual mode of operation, such as a user mode for non-privileged instruction and kernel mode for privileged instructions. These are the architectural support which are needed for multi-programming operating system. So, in dual mode of operation, the CPU has two modes. Mode 0 is for the kernel and mode 1 is for the user. In kernel mode, OS routines runs in kernel mode. Kernel mode is non-preemptive or atomic. Non-preemptive and atomic means like uh, if an instruction or a process is running in a kernel mode, then it cannot be deallocated from the CPU. While in user mode, user application run, and user applications are preemptive in nature. Means you can pause your movie and go and attend your phone call. So mode shifting. Mode shifting is like shifting from user mode to kernel mode and kernel mode back to user mode. This is a frequently carried out operation in every multi-programming operating system. Why mode shifting is required? Because of as OS is a service provider and it provides service to every or any process that requests its service in form of resources. Therefore, operating system has a mode shifting procedure. Second reason is user applications are services slash user activation. Whenever a user applications need an operating system, then mode shifting is done. If Mode shifting means like if you want to switch from one application to another, mode shifting is required to switch uh, to kernel and then to open the another application. Yeah. Okay. It's basic diagram. You just need to go through this. That's a basic C program. These all the instructions are executing in the user mode while it switched from one program to another. It required a mode shift because only kernel can load the another program into the memory. And in this, there are and within a program there can also be a switch between a user mode and a kernel mode. Initially, the program required only the user mode, but when the fork is a system call, uh, when to execute fork, a system needs to be in kernel mode. Therefore, a mode switching will take place here, and then again to execute another function, the system had to got back into the user mode. Okay, so all system calls executes in kernel mode. So and software interrupts. Software interrupts is so basically fork is a privileged instruction, and some privileged instructions generate software interrupts, and software interrupts is services serviced by ISR, which has two things: mode shifting and dispatch table. So whenever a privileged instruction is to be executed, you need to see it this way. Like whenever a privileged instruction is need to be executed, it generates a software interrupt. Not all privileged instruction generate. Some privileged instructions generate software interrupt, and that software interrupt is serviced by ISR, interrupt serviced routine, and that ISR has two things: mode shift and dispatch table. Okay. So yeah, this these 3 points are very important. A software needs software interrupts to obtain system services includes saving a file, uh, exporting a file, but and many more, which needs execution of privileged instructions. Even allocation of memory is also a privileged instruction. In order to change the mode from non-privileged, like from a non-privileged mode to privileged means user mode to kernel mode, a software interrupt is needed. A software interrupt is needed, and privileged instruction can generate software interrupt. For example, malloc is a function which allocates memory, but it may or may not generate software interrupts. Uh, System calls are usually invoked using uh, system calls. That doesn't make sense. Okay, anyway, every privileged instruction does not generate software interrupts. What was supposed to be happen is like, yeah, here is should be system call, यहाँ पे हमारा आना चाहिए था सॉफ्टवेयर. Software interrupts are usually invoked using system calls, and every privilege instruction does not generate software interrupts. Now we got into the difference between program and process, and we just quickly look over this. Program is basically, yeah, in Windows term .exe file or .apk file for Android users. It contains both instructions and data. Data can be static and dynamic. Static data, for static data we know it has a fixed size, and it allocated before the runtime, and the size is allocated, I mean the size for the data is allocated before runtime. For dynamic data types, the size can be known or unknown, and runtime allocation take place. So process is defined as program loaded into memory and executing, or we can say process is an instance of a program. Instance of a program refers to means, for one program there can be multiple processes running, so each process is an instance of a program. Scheduling, or we can say process is a schedulable or dispatchable units, or we can say process. What is the process? Process is a unit of CPU utilization, or we can say that process is also an animated spirit. Compiler determines the size but never allocates memory. During the compilation, the compiler only determines the size but never allocates the memory. It's an important thing you need to remember about that. Array, which are allocated in C++, is static in nature. To generate dynamic arrays, alloc, malloc, and calloc will be used. Yeah. Now we look over the developer view of process. Process as an abstract data type. Now we are looking a process as a data type. So it has its own definition, operation, attributes. Definition, implementation, operation, and attributes. Implementation means structure. How a process is structured. So definition, we have gone over here. Structures or implementation is like this. Process is divided into four parts. Code which contains instructions, data, heap, code, data, heap, and stack. Stack contains the activation record, local variable plus formal parameter. Heap is for dynamic data, and the data contains global variable or static variable. Operations of a process operations. Each process can do multiple operations. These are some basic and important operation that a process do. It create resource allocation, process operation, creation of resource allocation, schedule and dispatch. Process can be running, block, suspend, resume, and terminate. These terms are important when we are going to learn the process state transition diagram. Okay, process attributes. Process attributes contains a process ID, group ID, preprocessor ID, or we can say that a parent ID, size, type, state, program counter, register set, files, devices, and many more. Attributes of a process are stored in the data structure table known as process control block. Attributes of a process is stored in a process control block. Each process has its own PCB, and that PCB is stored in the system area, not the user area, in the system area, system area part of a memory in the OS area, as I've seen. And the volume of info in the PCB, the information stored in the PCB is known as context. And when we say context switching, is basically we are switching from one process to another process while saving the context of the first process. So context switching is defined as, if a process P1 is running, then we save the context of P1 at the time, at that the very instruction, and then load the new process. That is known as context switching. Now the process state transition diagram. Process state transition diagram varies from operating system to operating system. Uniprogram operating system is very simple. When a process is created, it goes to the it directly goes to the running. As in uni-programmed operating system, there is only one process, so there is no need for the program to be stored in memory, as only there exists to be only one program. Then that program can go for IO operations. IO operations happens in the block state, and that after IO completion, then that program can execute again, run on CPU, and can then terminate. So basically, there are only four states for uniprogrammed operating system. New, when a process is created. When a process is created, it is directly moved to the move onto the CPU, as it can only contain one process, and that running process can go for completion if that does not need an IO, and if that need an IO, then that process can go into the block state. And while that process in the block state, no new process can be created and goes into running state. And as even in the block state, the process needs to be in near as even in the block state, the process needs to be in main memory to do IO operations. And there can only be one process present in a memory. So therefore, while a process in block state for IO operation, the CPU will remain ideal, uh, which decreases our throughput, and then the process may go for completion to terminate. In multi-programmed operating system, there are more states. The main states that generated is the ready state. Whenever the program is in ready state, running state, ready state, running state, or a block state, it is to be presented in main memory. While when a program is in like a new state or a terminated state or even in the suspended state, the program is actually stored in the secondary storage, not in the memory. So when a program is created, it goes into the ready state. Ready state can contain more than one program. Then that program in the ready state can schedule or dispatch for to on the CPU. In multi-programmed operating system, there we are assuming there is only one CPU, so there is only one process in the running state. Then that process can be preempted due to time and priority and can go back to the ready state, as shown here, or that can go for IO operation or system calls to block state. In block state, there is a block queue and it can contain more than one program in a block queue. And as I have already stated, program in block queue are present in main memory. After IO completion, the program that is blocked came back in the ready state, and then it is again needs to be dispatched to the CPU to finally execute. So if like there is a program that is like first need to run on CPU and then goes for IO operation, then when a program cannot go to terminate without executing on the CPU, like if there is 10 units of a time that a process requires. So the initial 7 is to be executed on the CPU, and the rest 3 is for the IO. Then after completing all those 10, the process again has to go to CPU to go to termination state. The process to be terminated always has to be gone from the running states. Yeah, sorry for, yeah, from the running states to terminations. Process